This is Geometry, Unit 5, Day 4. We're looking at the properties of trapezoids. First thing we're going to do is draw in and talk about the characteristics of a trapezoid. A trapezoid has four sides, so it's a quadrilateral. It has one set of parallel sides. Those parallel sides are both called a base. So you have one base up there and you have another base down here. We would have what's called base angles that are on either side of the base. You have another pair of base angles on either side of that base. The sides are called legs. They are the legs of the trapezoid. There is a midpoint, of course, on any segment. And if you connect the midpoints on this trapezoid, that would be called a mid-segment. The mid-segment is also going to be parallel to the other two sides. When you have a midpoint, you're going to have two congruent sides on either side of that midpoint. Since the legs themselves might be different, the segments on either side of your midpoint might be different, but they're going to be the same on each side. An isosceles trapezoid, it's cool because it has one set of parallel sides, but the legs are the same length. So when you talk about the base angles, you're going to have congruent base angles. Here and here, and also here and here. We always know that the consecutive angles between the bases, they are supplementary. That's true for a regular trapezoid and also for our isosceles trapezoid. A kite has consecutive sides that are congruent. It just doesn't have all four sides the same. It has two sets of consecutive sides congruent. Two sets of consecutive sides congruent. Looking down at some of our theorems that we can talk about, if you have an isosceles trapezoid, you're going to have those two sets of base angles that are congruent. If a, let's say if an isosceles trapezoid, if you have an isosceles trapezoid, then it has two sets of congruent base angles. If you have one set of base angles that are congruent in a trapezoid, then you know for sure that that has to be an isosceles trapezoid. Think about what it would mean if this was a trapezoid, then you know you have consecutive interior angles that are supplementary. So if this was 60, this would have to be 120. Well, the same thing on this side. Now you have two sets. So the converse of this would be true. Another property that we can talk about is that if you have an isosceles trapezoid, then the diagonals have to be the same length. If you have an isosceles trapezoid, then the diagonals are congruent. That means a diagonal is a segment from one vertex to another vertex in a polygon, but it has to go inside the figure. So there's only two that are possible for a quadrilateral. In this case, if it's an isosceles trapezoid, those two diagonals are going to be the same length. There's one other shape that also has diagonals the same length, and that is in a rectangle. Since a square is a rectangle, it has it also. A shelf fitting into a cupboard in the corner of the kitchen is an isosceles trapezoid. Find the measures of N, L, and M. Well, if this is isosceles trapezoid, we know that the measure of angle K is going to also be the measurement of angle N, because those are considered base angles. So both of those are going to be 50 degrees. Since we have two parallel lines, we know that the measurement of angle L plus the measurement of angle K have to be supplementary. They're called consecutive interior angles. They add up to 180. Since K is 50 degrees, I can subtract the 50 from both sides to show that both of L and M are both going to be the same measurement because it's an isosceles trapezoid, but they're both going to be 30 degrees. On the next page, we're looking at a similar problem where we have two parallel lines. A and B are called consecutive interior. They're touching the parallel lines. So the measurement of angle A plus the measurement of angle B is going to add up to be 180. So since B is 135, then the measurement of angle A, by subtracting the 135 across, is going to come out to be 45 degrees. So the measurement of angle A equals the measurement of angle D, which is all 45 degrees. And the measurement of angle B is base angles with C, since it's an isosceles trapezoid, so we know both of those are 135. I've talked some about a mid-segment already. The mid-segment is the segment that goes across in a trapezoid from the midpoint to the midpoint. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if MN is a segment of our trapezoid, then MN has to be parallel to AB, and it also has to be parallel to CD. Half, the mid-segment equals half AB plus CD. The mid-segment equals half of base 1 plus base 2. That's the generic formula that you would use. So we can come down here and we notice that MN is our mid-segment. We don't know what its length is. So we're going to put in our base 1, which is 9, and our base 2, which is 16. So mn equals half of 25. So in this case, mn equals 12.5 inches. On this side, our 21 is our mid-segment. Remember that we have mn that is supposed to be equal to half base 1, which is QR, and base 2, which is PS. Well, the mid-segment is 21. QR is your unknown. PS is 30. So there's a couple different ways we could do this. We could distribute the half through, and we could say half of QR plus half of 30, which is 15. Another option is to multiply both sides by 2, multiply by the denominator. So if we multiply half by 2, we're just going to be left with QR plus 30. If we multiply the left side by 2, we're going to get 42. Then we can easily subtract our 30, and we get 12, which is 12 feet. You notice that this goes down by 9, and then it goes down by 9 again to get to the 12. About kites, a neat part about kites, property about kites, is that the diagonals will always be perpendicular. So if a quadrilateral is a kite, then its diagonals are perpendicular. The diagonals form right angles. So that box can go all the way around and show that you have actually 4 right triangles. You also will have one set of congruent angles. If a quadrilateral is a kite, then it has one set of opposite angles congruent. And the set that it'll be is always in between your two different lengths. It's always along the shortest diagonal. It'll never be along the longest. It'll never be B and D. In this case, it would always be A and C. Those would be the congruent angles. So when we come down to look at example number 4, we have a kite because we are noticing consecutive sides that are congruent. So we're sure this is a kite. The shorter diagonal, the diagonal that touches the angles in between the different side lengths, we know that these angles have to be the same. So we have 2 x's plus our 88 plus our 70, and they have to add up to be 360 total. So collecting our like terms and subtracting, we know we're going to get 202. So by dividing by 2, we're going to get 101 degrees. On this picture, again, between the 1 tick mark and the 2 tick mark, we know that those are the angles that have to be exactly the same. So in this case, we're going to get 2x we're going to get our 75 and our 85 that add up to equal 360. So that's 2x that adds up to be 160. By subtracting the 160 to the other side, we get 200, and by dividing by 2, we know both of those angles are going to come out to be 100. There's one more example I want to show you. If you have a kite, and there's our consecutive sides that are congruent, that makes it definitely a kite. We're going to look at the diagonals. So we know the diagonals are perpendicular. If one of them shows the box, they're all allowed to show the box. So that means we have 4 right angles. We have 4 right triangles also. Let's call this length 3 and this length 4. What would be the length of this side of the kite? Well, let's look at the triangle, which is a right triangle, 3, 4, and C. Well, there's a property called the Pythagorean Theorem. You've learned this earlier, actually in middle school, and we'll be discussing it in class in great depth in the future, but it does get applied to problems like these. So we know that the hypotenuse squared has to equal the leg squared plus the leg squared. We've talked about how in a right triangle the legs are the perpendicular sides. So those are your 3 and your 4. They're both going to be squared. The hypotenuse is always across from the 90. So that's going to be, in this case, considered our C. So C squared equals 9 plus 16. C squared equals 25. So we take the square root of 25, and C is just going to be 5. You may remember in algebra class that when you take the square root of an equation on both sides, you have to get plus or minus. But because this is geometry and we're talking about a length, we can't have a negative length. So I know that this length is going to be 5. That makes this length 5 also. I don't know what these lengths are. I would need to know another bit of information. Let's say that this part of the diagonal is 8. In a kite, both diagonals don't bisect each other. This one gets bisected. This side would definitely be 3. But these both wouldn't both be 4. This would be different than the 4. It could be 5, it could be 10. I'm going to call it 8. So I'm looking at this triangle. It's a right triangle. It has a length of 8 and a length of 3 and 8. Across from the 90 degrees, we'll call our C value. So the hypotenuse is our C. Our two legs are 3 squared and 8 squared. So C squared equals 9 plus 64. C squared equals 73. So we take the square root of both sides and we get the square root of 73. So in this case, this is the square root of 73, and so would that.